here on Kiwi. It's 9:14.
The Radio Wammo Breakfast.
The Geek Show.
Joining us from The Geek Show today, thegeekshow.com, 2 3s rather than 2 E's. It is Chelfyn this morning. Good morning to you, Chelfyn.
Good morning, Wammo.
And it was a couple of weeks ago, Chelfyn, that we were talking about nanotechnology and how nanotechnology is developing at the moment, and how we're going to start seeing some of these technologies coming into our lives, and we may in fact be using them. And I remember last time we were talking a lot about battery technology. Today is part 2 of this discussion.
Yeah, basically last week I filled in on quite a few new things coming up in the battery world. A lot of it to do with graphene, which is think of it as the chicken wire of nanotechnology. It's lots of carbon atoms in a flat sheet. And graphene was only really discovered about 5 years ago. And in that 5 years, we found it's got some amazing electrical and optical properties. Electrons can move through it at nearly the speed of light, which is about 100 times faster than electrons can move through copper.
Right.
Through silicon. So this, gives us the next generation of accelerating computer chips could be made from some form of graphene base.
Which would make them a whole lot smaller?
Yes, smaller, faster, cooler, using less energy. And there are graphene-based or carbon nanotube or carbon nanostructure-based solutions, potentially for both capturing sunlight directly or capturing energy from sunlight directly, and also for both the storage and the splitting of hydrogen, which is quite interesting stuff. So that's generally all on the battery side of things. What I wanted to go into this week was to start bringing in a couple of things that on the nanotech side revolving around magnetism. And this one is absolutely fascinating. They've found if you have a sheet of graphene and you remove a single atom from that sheet and leave a hole, there's a magnetic moment around that hole. So we've finally got a strange route into magnetism without ferrous metals without iron.
I like the sound of a magnetic moment. What does that mean, though?
A magnet.
Oh, sounds like we've
inertia. In the physics term, there's a magnetic force that doesn't just equal out into nothing. It actually there's an actual magnetic force in a direction. So by careful placement of holes in a sheet of graphene, we could use magnetic forces to make that sheet of graphene do something or be part of something.
Okay.
Now, we discovered the laser 50-odd years ago and more, and it hung around in labs for years doing nothing. This could be one of those things that just hangs around waiting for an opportunity to shine. It might take other technologies to evolve around it before that particular property of a graphene sheet gets used. Yeah. But currently, at the rate people are churning things out and at the rate things are going from the labs into industry, I don't think we're going to see it taking as long as lasers did this time round. Yeah,
which would be a good thing.
Oh, yes. Some of the things that this promises is phenomenal. Now, for the first time in this whole nanotech thing, I'm going to step outside talking about carbon and talk about another magnetic breakthrough, really. A group of scientists from the University of Minnesota have created, basically, instead of just iron, for every 16 iron atoms in a crystal, there's 2 nitrogen ion atoms that are squeezed into this crystal. And in this form of Fe16N2, 16 iron, 2 nitrogen, the crystals are more magnetic than the most magnetic material previously known. And it's more magnetic than the predicted limit of maximum magnetism for any material.
Wow, so this actually blows any kind of theory out of the water that people previously had about magnetism.
Well, they're having to search around, not so much for new theories right from the very beginning.
Yeah.
But a few new theories to explain why in this particular form, with these extra nitrogen atoms stuck into the compound, why it's blown some of the theories out of the water. So we've now got the possibilities of magnetic materials on a nanoscale for microelectronic and micromechanical things going on, and magnets stronger than we've ever had before, which leads to smaller, more powerful motors. Now, it's that last word, really, I think that's the big thing that I'm getting towards. What we've been talking about here is batteries that can store more and more in lots of different ways of getting hydrogen and storing it in different ways to move energy around without necessarily having to just charge up capacitors or shipping liquid hydrogen around in big frozen tanks, which it leaks out of an alarming rate, no matter how much you seal them. And really strong motors. This is leading towards electric vehicles, which are far more efficient and powerful and light than our current ones. In fact, just generally electric machinery. This could lead to electric planes and helicopters.
Oh, wow.
And
okay.
things like that.
Yeah, and hopefully coming online just when we need it, just when peak oil may be starting to hit.
Yeah. I mean, it's almost looking like we're around peak oil now.
Yeah.
That there's plenty of signs in that direction. Even if we're not, saving all that oil to use for more useful things than just burning for fuel and heating, and the wasteful use that we get out of it in cars, where you use it to accelerate a mass up to a particular speed, and then you come up to some traffic lights, and all that energy you put into accelerating your car gets turned into heat in the brake discs and noise, and goes nowhere else.
Yeah.
Even if you were charging up your batteries from an onboard diesel generator, at least if you had electric motors in and good battery technology, every time you brake, you can turn that energy back into electricity, or back into a chemical form of electricity or stored electricity in capacitors.
Wow.
Instead of it turning into heat. And then you can use that to accelerate back up again. So we can use this technology, first of all, to make our current fuel use far more efficient, and slowly move our fleet onto electric vehicles.
And really making things in transport as efficient as possible.
Yes, which is the key to not, for our whole, our whole world to not have to take a step back because of running low in energy in the future.
Yeah.
It also shows that while many people see this rise of technology and the rise of screens around us and computers, they see it as an ongoing rise in energy use by the world.
Yes.
This is going to turn a corner as the screens become more efficient, as our computers become more efficient. We'll start using less energy for these things. We're already starting to see that with the rise of netbooks and the popularity of netbooks, proving that people have gone, I don't need all this power. I'd rather have a smaller machine with a battery that lasts longer.
Yeah.
I just need to get onto the internet.
Absolutely.
So the rise of these machines has shown that, once you hit a certain point in computing power, you can make useful devices that don't have to suck up all the energy possible. And look at the energy span. I swore I wouldn't mention it, but look at what they're getting out of the iPad. They're getting
yeah. Well, this is true.
10
it's actually
10 hours plus.
Yeah, 10 hours plus, and it's also like the netbook, you say, reducing size and making functionality more simple and more streamlined to what users want at the end of the day.
Yeah. So have we got time for one last story?
One last story.
It's a quick one. Tomy, the Japanese toy makers, have unveiled a little radio-controlled car with a bio battery, seeing as we're on the car topic.
Yeah.
And it's fueled by sugars, so you can pour in, a can of soda, and it runs off this basically a bio-battery that generates electricity from sugar by using enzymes to break down the carbohydrates and release energy in exactly the same way that the body breaks down sugars.
Brilliant.
So it's in prototype stage, and it's not known when or if it'll be available for sale. But
I really like the thought of that.
If you've got a leftover can of Coke, just chuck it in the car.
Chelfyn, thanks so much. TheGeekShow.com, 2 3s rather than 2 E's. Of course, Chelfyn on Twitter as well, twitter.com/CHELFYN. Chat to you next time.
Okay, cheers.